Hi again, river processing, and we're going to be looking at in more detail at the individual modeling files that are created. And by going through river processing in our project and going down to the right hand end where we're seeing the word Hecras, we'll look at all the rest of them on subsequent videos. It's really quite important to find out what is happening with the Hecras data. It's produced by the US Army Corps of Engineers, and this is the little bit of software that it looks like here. So if you're creating Hecras, you're going to be creating something that looks like this, and this is the raw Hecras survey data, a .go1 type text file. And what you get bits at the top there, those get filled in, river reach, all the rest of it. And here are the coordinates in pairs that actually go from the top left here, easting, northing, all the way down to the bottom of that list, and then back up on the right hand side. Don't ask me why they're in that format. I've got no idea. Then the river reach, the individual cross-section information is in this format, in a data chunk like that. Now, at the moment, we're not creating the bridge modeling data. We're trying to get there, but it really is quite complex. But this is the very simple format of a cross-section that actually does go from left to right, the offset value and the level, the bed level. It's that simple. And then the next one there on the right. Now these are in 2, 4, 6, 8, 10 in 10 columns there. It varies as it on different aspects of Hecras, but this is the basic individual cross-section building block. And when it's read into Hecras, you get this it's almost DOS-based programming. It started there many years ago, and this is basically what you get. I can edit, I can bring some data in, and you get what is basically a Mickey Mouse plot of the data. And they try to interpret these coordinates here, and they go in there, and sometimes we have to set the geometric extents, and that's how it is. Rivers running north to south, and you end up with your green cross sections over to the open channel. And if I open, we can see this. If we move it up a bit, I'm on the limit with what I know about all this. But here's an open channel. This is what the data looks like when it gets imported. The American words, why there's a river called Bogue Chitto, we don't know. But everywhere where they got STA, it's river station. A river station is a chainage of the cross-section up the watercourse, but also a station is the offset value on the cross-section itself. So you get, here's it's actually a structure. We can go, if I do this and then go down or up or 1 or 2, there we are. You can see it's live with the diagram. It's more of a diagram than anything. And so here is all the data. If you click on here or click on any of these, you can see things. But this is the basic building block, as I said, of the Hecras format. And when they get into the programming of the structure, there's an inline structure here. Let's come down to it. Right. All I know is that this is something to do here with the inline structure and the geometry of it. And you've got Manning's values in here. They're mostly, it seems to be large chunks. LOB means leftover bank, ROB right over bank point, and so it's not like the flood modeler where you've got its individual points. So in a sense, when we export the Hecras data, all that is lost. All our hard effort in surface and vegetation coding appears to be lost. But nevertheless, here they are. There's these arrows here indicate a structure, a point of the bridge structure support in the middle, and this is what they're doing. So really, and if we go down to the bottom, you can see it starts at the bottom 101D and comes all the way up to 52 at the top there. That's really all we need to know about the problems or the issues of getting data into Hecras, and it is actually really quite complicated. So we'll finish all that there. Thank you for the moment.